Hey everybody, Mr. Judson here. So today we're pushing forward with this idea of graphing the basic functions. And right now in our basic function toolbox, I guess you could say, we know how to graph linear functions using a y-intercept and a slope. We know how to graph parabolas, and we know how to graph absolute values. Okay? And the idea is that once we do this, we don't just do it and do the assignment and forget it. It's if I have to graph a parabola at some point in the future, I remember what we talked about, and I can easily produce that graph. Okay? We want to build a toolbox with probably about 8 functions in there that we can graph easily. So the one that we want to talk about for today is the square root function. And again, our goal is to say, what happens if I fill this equation up with numbers, put them in all the different places possible, how does it affect what this graph looks like? So we're going to try and figure out what a times the square root of bx plus c plus a d value would look like. And you're going to start to notice this pattern. The number that's out in front is always the a value. The number that's kind of grouped either inside parentheses or inside the absolute value or inside the square root is always bx plus c, that expression. And there's always this d value that's kind of out by itself. Okay? So before we do this, we need to go look at the parent function. What does y equal the square root of x look like? Well, first of all, we want to make sure we understand that you can't plug a negative number in there. Remember we talked about the domain? Whatever's inside the square root has got to be greater than or equal to 0. So when I set up my xy table, I'm going to plug in numbers like 0, 1. Let's see, I want to keep this easy. So the next number I know the square root of would be 4. And the next one after that would be 9. And that's probably going a little too far, but we'll at least use that as a way to see what this graph looks like. So 1, 2, 3, 4, 1, 2, 3. All right, so if I plug a 0 into this, the square root of 0 is 0. If I plug in a 1, the square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. And so now if I plot some points here, here's the point 0, 0. 1, 1 would be right here. And 4, 2 would be right about there. 9, 3 way out here somewhere. And so this graph looks like that. There's nothing over here in the negative area for the x-axis because you can't take the square root of a negative number. It starts at 0 and it goes off in that direction. And so now what our goal is to figure out, okay, well if I start putting in different numbers for A, B, C, and D, what happens to what this graph looks like? Like how does it affect the graph? All right? Now I want us to start by talking about what's normal. Just like we do with the parabola. However far you move over, you go up that distance squared. Well, what's normal for a square root function? The idea is this. However far you move away, we're going to call this the starting point because the graph starts here and then goes off this direction. However far you move away, then what you need to do is you need to go up the square root of that number. Okay? Even if you only go 3 units. Now, I don't want to choose 3 because it's not an easy number to work with. But if I did, so if I do the square root of 3, I get 1.7 about. So if I was to go 3 units over from this starting point, I have to go up 1.7, and there's going to be a point right there on the graph. Now, for me, I'd rather pick something easy. Let's say, okay, if you go over 1, the square root of that's 1. If you go over 4 units, the square root of that's 2, so I go up 2 units to get a point. And if I went 9 units over, the square root of that's 3, I'd go up 3, and there's going to be a point there that will be on that graph. Okay? That's what's normal. Now, if you remember with the parabola, we had to talk about, okay, well, what if there's an a and a b value in there? How does that affect what's normal? And remember I told you, all you got to do is look at the graph and you'll know, or look at the equation. whatever's written here, that's how many times more or less you're going to do than what's normal. So I need to multiply this by a times the square root of b. A root b. So let's just say that there's a number here where a is 3 and b is 4. Okay, well, 3 times the square root of 4. Square root of 4 is 2. 3 times 2 is 6. That means when I go up, I need to go 6 times farther than what's normal. So if I went over 4 units, square root of that's 2. Well, now I got to go 6 times farther, so 6 times 2 is 12. I'd have to go up 12 units to find another point. That's what we mean by this piece right here. Okay, we'll do some examples with it in just a minute. All right, so first of all, I want to use our graphing calculator to figure out some things about A and B. And so what I'm going to do is I'm going to graph. All right, with y equals, I'll clear this off. I'm going to say, let's graph the square root of x. We know what it looks like. That's our parent function. Let's just kind of verify that yep, that's what the graph looks like. So zoom option 4, and that's what it looks like. It starts at the origin, goes off this direction. Okay? So what happens if I put a negative sign out in front of the square root symbol? So now I've just said that a is a negative number. Well, with our parabola, it flipped it across the x-axis, right? And remember what I told you guys on our last video? I said the reason I'm using A, B, C, and D is because once we set our rules, nothing changes except what the graph looks like. So what happens if A is negative? Well, it'll flip the square root across the x-axis. So let's just check and see. I've got a negative sign out in front. I want to graph this. That's what happened. The function was up here, but now it's flipped across the x-axis. All right? So let's write down some rules for this. So if a is greater than 0, so that means it's positive, then my graph is going to look like this. If a is less than 0, so that means we've got a negative number right here, well then my graph is going to look like this. So a tells us whether this thing goes up or whether it goes down. What about the b value? So I'm going to go back to my y equals, I'm going to delete that negative sign, and I'm going to put a negative sign right in front of the x. To be able to type things in front of something, you have to do second function insert, right here where the delete key is. That's what allows me to type in there. So now if I put a negative sign, I've got the square root of a negative x. All right, so what does this look like? Let's hit graph. Oh. Now, I don't feel like that should surprise us because one of the things I said when we were working on the parabola is if the b value is negative, it takes your parabola and flips it across the y-axis. So if you think about a parabola, if I flip that across the y-axis, it doesn't really look any different, right? It would look the same. You know, if you think about the square root function, if you think about the absolute value function, it looked like this. And so if the b value is negative, it means I have to flip that across the y-axis as well. Would it look any different? No, it would look the same. Okay? But now when we have a square root function, if I'm going to flip that across the y-axis, it is going to look different. So let's write down another rule here. So if b is greater than 0, then our graph is going to go like this, off to the right. If b is less than 0, well then our graph is going to go off to the left. So really, A tells us, does this thing go up or down? And B tells us, does it go to the right or to the left? You know, could we be down here in the third quadrant? Yeah, if A is negative, it's going to go down. And if B is negative, it's going to go to the left. So if both A and B are negative, that puts us in the third quadrant. All right? So one more piece of information we need. How do you know where to start? We need to have a starting point. That's something that's probably pretty important. Well, remember, I told you guys with the parabola, I said, I'm always going to ask you, where do you think this key point would be located? And what you guys would then say is negative c over b comma d. Right? As I write this down, whatever's inside the grouping symbol, that tells me what the x-coordinate is for my starting point here. So let's just draw this. We're going to call that a starting point. And that's going to be at negative c over b comma d. So if I can find the starting point, and I know whether this thing goes up or down, or left or right, the only other thing I have to do is just ask myself, is it a normal square root function, or do I need to do a little bit more or a little bit less than what's normal? And again, what's written here in black, we try to keep that simple. So you know, I want it to be things like twice as much as what's normal, maybe 3 times as much, or half as much. I don't want it to be 17/58 times as much. What? You know, how am I supposed to do that? When numbers get messy like that, that's when we just go straight to the graphing calculator and get our graph that way. Okay, so the goal is to keep this pretty easy. All right, let's do a sample one here. All right, so I'll keep the first one fairly easy. I want to graph y equals the square root of x plus 2 minus 3. So just like before, I'm going to write down a little bit of information. And I think you guys should do this as well. You know, in terms of how do I show my work, well, write down a couple key pieces of information and then go produce the graph. Right? So my starting point is going to be negative 2 over 1 comma negative 3. A is positive, so is B, so that means I'm going up and to the right, so my graph will look like this. And since my A and B values are both 1, this is just going to be a normal square root function. Nothing fancy happening here. So let me get a graph. I want to start at negative 2 comma negative 3. So negative 2 comma negative 3 right there. I'm going up and to the right. And so now I just need to think what's normal. Well, if I go 1 unit over, I need to go up the square root of that, which is 1. The next number I know the square root of is 4. So I'm going to go over 1, 2, 3, 4 units. Square root of that's 2, so go up 2. And you know what, a lot of times I get people to say, oh, Mr. Judson, how am I supposed to know whether I square root the distance or square it because it's a parabola? How do I keep that straight? And I'm like, well, just look right here. This is telling you what to do, right? However far you go over, you do the square root of that, and that's how far you go up. Okay, there it is. I'm done. That was easy. Let's try another one. All right, so here's our next function to graph. And by the way, my wife says to me sometimes, she goes, isn't that confusing when you write f of x sometimes, and sometimes you write y equals? I always say, why would that be confusing? They both mean the same thing, right? So when you see that, don't let that be confusing. It's the same thing as y equals. You can erase it and put a y in there if you want. That's okay. All right, so we look at this equation, and probably your first thought is, oh, Judson, you're trying to be tricky here. You're trying to get us. Yeah, I am. And so one of two things happens. Either someone goes, oh, that's not tricky. I got this. You're not so sly, Mr. Judson. Like, okay, show me. Graph that function. Or we go, well, that's not fair, man. You gotta give us an easy one, you know. And, hey, this pre-calculus, we're pushing everything a little farther. All right? So I often tell people this, if you don't like the way this looks, write it the way you want to see it. Because I would agree, I don't like where they put the x. I don't like that. So I'm going to say this is the same thing as saying a negative 2 times the square root of a negative x. This is positive, so plus 4 plus 1. Now we got everything in the right spot. Now we're ready to graph this thing. All right? You guys take it from there. All right, so I'm going to do the same thing I did before. I'm going to say that my starting point is at negative 4 divided by a negative 1, comma 1. Real important we keep track of that negative sign as well to determine our starting point. So that's going to be at positive 4, comma 1. So now I look at this and I'd say this graph goes down. This is up or down right here. This is left or right. So down and to the left. So when I graph this, it's going to look like that. And then my last thing to consider is it a normal graph? This is where I ignore the negative signs. I just want to think, okay, a square root b equals 2 times the square root of 1. I'm ignoring the negative signs. So that's 1 times 2, that's just going to be 2. So I need to do twice as much as what's normal. All right, I'll start here. We're going down and to the left. And as I go across and decide how far down I need to go, I need to do twice as much as what I would normally do. So I'm ready to produce a graph now. All right, so my starting point is at 4, comma 1, which is right here. I want to go down this direction. So if I go over 1 unit, the square root of that's 1, but I need to go twice as far as what I normally do. So I'll go down to right here. The next number I know is if I go over 1, 2, 3, 4, the square root of that's 2. But I need to go twice as far, so I'll go down 4 units. And if I want one more point, I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because I know what the square root of 9 is, right? How far did I go? 4, 5, 6, 7, 8, 9, right here. So the square root of 9 is 3, so I'll go down 1, 2, 3. But I need to go twice as far, so I'll go another 1, 2, 3 to right here. Now, do I have to find this point way down here? No, you don't. But this is important. If you don't find that point and you draw your graph like this, you made a mistake right here. That's not really where the graph goes. The graph should be going towards this point right here. So what I always tell people is, if you don't want to find this point, then don't draw the graph all the way to it. Stop right there. Okay? Don't keep on going if you don't know where you're going. It's kind of like when you get lost in the car. Well, I'll just keep on driving. That doesn't make any sense. All right? People do that. I bet your parents have done that. I've done that. So stop right here and put your arrow in there. Or just make sure you hit that point. So we went over 9, we went down 1, 2, 3, 1, 2, 3, right here. Just make sure that when you draw this curve, that you go down towards that point. And then we're good. Okay? But I don't want to bend this curve up and go towards points that I'm really not supposed to hit. Okay? Now, just to make sure you guys get this, if I would have said, I'm going to go over 7 units. All right, so now I need to go down, let's see, the square root of 7, which is 2.6, roughly. but I need to go twice as far, times 2. So really I should go down about 5.3 units. So I'm going to go down right here, 5.3 units. Now, why didn't I choose a number like 7? It's not easy. It's not an easy number to work with. If I didn't have a calculator to figure out the square root of 7, I wouldn't have known what that was. I don't know those answers, right? But I do know the square root of 4, and I do know the square root of 9, so I want to make sure I pick easy numbers to work with. But even if I pick one that's not easy, it should still work. 1, 2, 3, 4, 5, and a little bit. Okay, I might be off by just a tiny bit on this, but I'm not off by much. All right? So yeah, I don't want to pick messy numbers, but I could. All right, let's try one more. This time I've got f of x equals the square root of a negative 4x plus 8 minus 2. You guys go ahead and see if you can graph that. All right, so I'm going to do the same thing. I want to know what my starting point is. Negative c over b, so a negative 8 over negative 4 comma negative 2, which that's going to be a positive 2 comma negative 2. And which direction does this thing go? It goes up, because that's positive, and to the left. So up, to the left. My graph's going to go this way. And then when I do my a root b, so if nothing's written there, it's always understood to be a 1 out in front. Just like if I say the variable x, what's the coefficient in front of it? If it's not written there, it's understood that it's a 1. Same thing here. So I've got 1 times the square root of 4. Remember, we're ignoring the negative sign right now, because you can't take the square root of a negative number. I already know what the negative sign does. It makes it go this way. So that's going to be 1 times 2. So again, we're doing twice as much as what's normal. And so now I'm ready to graph this. Starting point is at 2 comma negative 2. So 2 comma negative 2, it's right there. Whoop. And we're going up and to the left. So if I go over 1 unit, 1 squared is 1, but I need to go twice as far as what's normal. If I go over 4 units, the square root of that's 2, but I'll go twice as far as what's normal. And I'm just going to stop right there. There's my graph. So the way that I grade this, if this was a test, is I'm just going to go, do you have the right starting point? Yes, you do. Is it going the right direction? Yes, it is. Did you draw a square root function? If you do a parabola here, that's a problem. So I've got to recognize what function I'm drawing. So I'm drawing a square root. I know my starting point. I went up and to the left. If all somebody did was go like this, you've got most of the credit. If you're lucky, you put that exactly in the right spot. Right? You knew what a square root looked like, you knew where to start, and you knew it went up and to the left. But what you didn't do is you didn't find these points. Now it looks like you hit that one okay, and 2 comma 2, I'm really not sure about that. I might go like this, oops, I might go like this, and put a question mark there because I don't know what that point is. But you're going to get most of the credit just for doing that. We want to get all the credit, okay? We want to make sure and find those points and make sure our graph hits those. All right, that is what we have for today. Only one function today. So what we're going to do is we're going to graph square root functions, but just to make sure we don't forget the parabola and the absolute value, everything we do graphing, I'm going to throw something from the past in there. So you may see a few parabola functions to graph. You might see an absolute value in there. When we do our next thing on Wednesday, you're going to see some square roots in there, and some parabolas and some absolute values. Okay? So we don't want to forget those rules. We want to make sure we've got all that stuff straight and we keep on practicing it. All right, let me get you a homework assignment. So here's our homework assignment for tonight. Again, we got 10 graphing questions. You can see I do have a couple parabola pieces in here. And so I don't have any absolute value functions, so I guess we'll see that later on. I do want to talk about one thing. This right here, a lot of times people look at this and they kind of get stuck on that. Well, that -3, you can actually just pull that out in front and call it a -1/3. It's our a value, right? If you take half of something, that means divide it by 2. But the word of means multiply in math, so that's the fraction 1/2 times whatever. So dividing by 3 is the same as multiplying by 1/3. Dividing by 5 is the same as multiplying by 1/5. Dividing by 2 is the same as multiplying by 1/2. All right? Also, a decimal number like this, you can think of that as a fraction if you want, but you don't have to. Think of it as 1/4. All right, so there it is. Go ahead and take a picture of this, or it'll be on my classroom website, and you can also print it out from there, and that way you have that piece of paper. All right, you guys, that's all we have for today. I'll see you later. Stay safe.